Good evening, everyone. Welcome to the Carolina Weather Group. We're happy to have you. As you know, tropical season starts June the 1st, so we are right around the corner. And tonight we have with us Dr. Phil Klotzbach from Colorado State University. He's going to be giving us his 2020 outlook for the upcoming hurricane season. We're also guest panelists Carl Schreck from NC State University, as well as our regular panelists tonight. We're going to be discussing this. As you know, here in the Carolinas, we can never turn our back towards the hurricane season, as when we're not in it, we're remembering from storms from previous years. So it looks to be another active season. So with that, Dan, I think we'll go ahead and kick it off with you and let you start the interview.
Thanks for coming with us, y'all. I guess the first question is when is the hurricane season start? Kind of a simple question here, but I think it's good for everyone to know because we usually think of it later on in the year. But when does it actually start?
Well, the official dates of the hurricane season, it officially starts on June the 1st and ends on November 30th. We can have storms that form outside the canonical hurricane season. You can get storms sometimes in May, sometimes in December. Every now and then you get them in January, February, March. But in general, June 1st and November 30th is the official hurricane season. But one thing we always try to emphasize is that the hurricane season is 6 months long, but 95% of all your major hurricane activity, your category 3, 4, and 5s, occur after the 1st of August. So often we've heard a lot of students say June, July, oh, then nothing happened, it's a dud season. No, not necessarily. June, July often is very, very quiet. The season really doesn't ramp up until August. And Bill Gray, who founded the seasonal forecast, he used to we used to do tropical weather briefings every weekday in our department. And on August 20th, he would come down and ring a bell. It hung in his office for many years. It hangs now in a memorial to him outside of where his office used to be. He would ring a bell August 20th, signaling the active part of the season, because even the first half of August is often fairly quiet, and then stuff really ramps up.
As we're approaching that date, there's multiple different hurricane season forecasts that are coming out. I know CSU, you guys produce one, Phil. NC State has one. Carl, I know you don't exactly produce those numbers, but you know some of the discussion that goes into that. So Phil, I guess I'll start with you. What is CSU thinking is going to happen in this upcoming season?
And so our group at CSU, we put out our forecast in early April. And at that point, we're called for 16 storms. Of those 16, 8 becoming hurricanes. And of those 8, 4 becoming major category 3, 4, 5 hurricanes, winds of 111 miles per hour or greater. The average hurricane season, which NOAA defines to be the previous 30 years, but in 10-year chunks. So right now it's 1981 to 2010. As of next year, it'll be 1991 to 2020. The 1981 to 2010 average is for 12 named storms, 6 hurricanes, and 3 major hurricanes. The long-term average number of named storms will be going up quite a bit when we shift to 91 to 2020, and that's because starting around 2000, we got these really nice microwave sensors. So basically, we can look down into these storms and better detect these kind of weak, warm core systems that we had a whole pile of last year. And so if you look historically, the number of these weaker named storms has gone up, and especially in the last 20 years.
Interesting. And Carl, what is NC State kind of looking at?
So NC State, the official group looks at a variety of teleconnection indices like everyone else does. I think really the biggest signals that everyone is honing in on this year is the fact that the Atlantic is looking a lot warmer than usual, as it has for most of this, the last 20, 25 years or so of this positive phase of the Atlantic multi-decadal oscillation. So that's one factor. The other factor that's usually really top of mind is what's happening with ENSO. And when there's an El Nino, things can, the enhanced vertical wind shear really damps down the amount of hurricane activity that we get in the Atlantic. This year, that looks very unlikely. The most likely scenario is either an ENSO neutral phase or possibly a La Nina, in which case the vertical shear would actually be decreased. So in either of those scenarios, basically ENSO isn't going to be getting in the way of the hurricane season. And so all that warm water in the Atlantic is going to be, free fuel for the storms potentially.
One thing we always like to do is look back at previous seasons and see if there's any analogs to those seasons. Have you guys noticed any previous analogs that could relate well to the 2020 upcoming season?
Let's see. So one of our analogs, so basically for analogs, I looked more at what the conditions I expect to see for the peak of the hurricane season. So right now we have basically what's known as warm neutral ENSO conditions. So, to get an El Nino, it's not a crazy warm anomaly. 1 degree Fahrenheit is enough to declare an El Nino, which seems like nothing, but in the tropics, 1 degree, 2 degrees is a huge difference in how the tropical circulation responds. And that's what then really is why we care about it for the Atlantic, because El Nino takes place in the tropical Pacific. So the reason we care about it is because when El Nino happens in the tropical Pacific, it basically shifts where the deep thunderstorms form. It shifts them further towards the central Pacific from the western Pacific, and therefore you get these increased upper level westerly winds from the central Pacific that hook into Caribbean and into the tropical Atlantic and really start shearing and tearing apart these hurricanes. And so for the hurricane season, I think an El Nino is really unlikely. We're thinking probably neutral, or at this point I would say maybe even a weak La Nina, just given the way the current water structure looks like in the tropical Pacific. And if you look at, so the 5 analogs we chose were 1960, 66, 1980, 1996, and 2008. 4 of those 5 years were active seasons. 1960 was about average.
And Phil, we were talking about some of the factors. You were talking about La Nina, the warm sea surface temperatures in the Atlantic. But something that's really piqued a lot of interest, especially right now during the spring season, is the warm Gulf waters with the uptick in severe weather. But these warm Gulf waters don't anticipate to cool off any. So this is kind of like a hot tub if any storm gets going in the Gulf. Is that correct, Phil?
Yeah, so certainly Gulf of Mexico water temperatures have a pretty strong correlation with severe weather. So when you have a really warm Gulf, it's basically more moisture, more fuel for the storms or for the tornadoes as they're firing off. The Gulf of Mexico water temperatures, if you look at correlations between those water temperatures and Atlantic hurricanes, Gulf of Mexico hurricanes, there's very actually little correlation there. And that's because the Gulf of Mexico, as most of you know, is a bathtub. It's very, very hot. It's plenty warm to support any nasty hurricane you could want in any year. Thankfully, the other conditions that we need to get hurricanes normally, or most of the time, aren't there in the Gulf. You have to have low enough shear, enough moisture, and also a disturbance. Often in the Gulf, there's just not the organized disturbances that you need.
Phil, is there like an ideal water temperature for these tropical systems to get going? Like you said, the cooler shelf waters. Is there like I know there's not a magic number per se, but what's the ideal temperature for tropical systems to really get going and spinning and generating?
Yeah, so it's typically been so Bill Gray said it at about 26 and a half degrees Celsius, so roughly 80 degrees Fahrenheit. It's kind of like the bare minimum to get a hurricane to develop. And then basically the warmer the waters, the more conducive it is, all else being equal. But you can get storms, especially in the Atlantic, that form with cooler water temperatures and sustain at cooler water temperatures because you get interactions with mid-latitude fronts that can help keep the storms spinning. And also you can get, it's not just the water temperature at the surface, it's what the water temperatures are high up in the atmosphere. And so if the water temperatures high up in the atmosphere, or sorry, not the water temperatures, the air temperatures high up in the atmosphere are much cooler than normal, that can give enough instability that the storm can survive even if the water temperatures are a little bit cooler. So that's why you can see sometimes in the Atlantic, these storms can be over water that's maybe 65, 70 degrees and still be maintained as tropical cyclones because the upper levels are very, very cold. And if you look at the Atlantic versus other basins, the Atlantic has more storms forming at colder water temperatures than any other basin. And that's just because you get colder temperatures aloft, high up in the atmosphere, and also you tend to have a lot more frontal kinds of storms, these kind of ugly hybrid storms that form in the Atlantic compared with in most of these other basins.
Carl, one thing that we look at in these hurricane outlooks is ACE points. Can you maybe talk to the followers and the listeners on the podcast version who may not be familiar with that?
Yeah, so ACE is accumulated cyclone energy. And what it is essentially taking the wind speeds, the maximum wind speeds from the storm at every 6 hours throughout its life cycle and throughout the entire season. And what we do is we square the winds and add those up through the whole season. We square it because if you remember back to like introductory physics, energy is 1.5 mv squared. So we're kind of getting that v squared component in there. And so what that's useful for and why we kind of lean on it is it's a really integrated metric for the entire season. So if you have like a really short-lived storm that, gets really strong and then weakens rapidly, it's not going to contribute as much as a long-lived storm. And what we tend to find with ACE is that, really you get this strong correlation between intensity and longevity. And also the frequency of storms matters a little bit as well. Like if you have a lot of hurricanes, that's going to contribute to your ACE. But if you have a lot of, middling tropical storms like we did the last couple of years, that's not going to contribute nearly as much. So like last year, Phil can probably correct me on the exact percentage, but the vast majority of the ACE that we got last year was from 2 storms alone, Dorian and Lorenzo. Everything else was virtually nothing really. So really those 2 storms by themselves really put us over the bar for an active season. And I don't remember the exact numbers offhand, but a typical season is somewhere around 100 ACE units. And, we're looking at potentially quite a bit more than that this season.
Yeah, and just to follow up on what Carl's saying, like when you look at these ACE numbers, you can have these storms. The record in the satellite era is Hurricane Ivan. And then that was so Hurricane Ivan in 2004 was basically came right off the coast of Africa, hit the ground running, went all the way across, and eventually made landfall near the Alabama-Florida border. Likewise, if you remember a couple of years ago, Hurricane Irma, seemingly that thing was out there, felt like it was out there for 6 months. It was only out there for about 2 weeks, but hit the ground running, came off Africa, and was just this monstrously intense storm for a very long time. These suckers generate a ton of ACE. So Irma by itself, or Ivan by itself, generated enough ACE, if that had been the only storm of the year, to generate enough ACE to meet the NOAA definition of an average season. When we're doing a seasonal forecast, we're basically looking at how conducive the overall environment is, and it's harder to determine whether Mother Nature is going to do it in a few really long-lived storms or just a bunch of shorter-lived storms. So ACE is kind of more of a robust metric that kind of takes all that into account.
A question for either of you. Is there a location that we should focus on more this year, or is there a location you pinpointed that may be at a bit of a higher risk from any tropical cyclone?
I think this year we're going to probably be looking, the last 2 years, the main development region, so the area right off of Africa, off the all the way to the Caribbean, hasn't been particularly active. The Caribbean the last couple of years has actually been pretty quiet, thankfully, after 2017 where they got absolutely run through the ringer. But I think this year the conditions in the deep tropics are likely to be more conducive than they were the last couple of years. So the last couple of years we've had a lot of storms, but most of the storms have been outside of the kind of the canonical deep tropics. I think this year we're going to have to pay more attention to the canonical deep tropics stuff coming off Africa and in the Caribbean. Unfortunately, we can't say where the storms are going to make landfall. I know it's everyone wants to know, but basically the seasonal forecasts have skill because what we're doing is effectively trying to forecast a large scale environment in the tropics, and then the environment's more conducive, you tend to get more storms, but trying to pinpoint exactly where those storms are going to form and exactly how they're going to track, that's just something we can't do more than a few days in advance for the track of the storms, unfortunately.
And of course, as you mentioned, it is very hard to forecast this far out, but there have been many storms over the past years that have formed off the coast of Africa and then eventually moved towards the Carolina region. So kind of connecting some dots like we should every year, this year, perhaps another year to remain on alert in the Carolinas.
Yeah, I would definitely agree. I mean, basically, if you look at the storms that tend to hit North Carolina, a lot of them do form off the coast of Africa and take the kind of that long trudge across the basin. And so, even with a storm like Irma, it seemed like it was out there forever because it formed, and then it was like, looked like all the miles like this storm's going to be bad, but it's like, people don't realize how long it takes a storm moving 10, 12 miles an hour to move across the Atlantic Ocean. I mean, it's not as big as the Pacific, but it's a big ocean. So, these things come off Africa and you have to be patient. It takes a long time till they hit anything. So, we're obviously monitoring the storms in real time during the season, but, just because a storm forms off Africa, it's not going to be there tomorrow. It takes a while to cruise across the Atlantic Basin.
The other thing I'll add real quick to that is, like the last couple of years, the subtropical Atlantic is really warm as well right now. And so I think that also increases the risk to the Carolinas where, certainly Florence had some very unique flow patterns that steered it towards the Carolinas, but having a storm that's already kind of at eye level with us this far north is probably a greater risk again this year as it has been the last couple of years.
As we kind of recap all of the discussion tonight, we're definitely looking at potentially an above average season. Phil, you guys over at CSU, 16 named storms. And over at NC State, 18 to 22 are being forecasted. One last kind of question before we close, and I'll throw this to you, Phil, because we're talking about this before the show. Why is it important to maybe sometimes focus more on the number of hurricanes and major hurricanes that you guys are forecasting versus just the total number of named storms?
Yeah, and I think it kind of goes back to some of the discussion we had about that accumulated cyclone energy metric and just the overall damage that these storms cause. If you look at major hurricanes, the category 3, 4s, and 5s, on average, they make up about a quarter of all the storms that form in a particular year. But they do about 80 to 85% of the historical normalized hurricane damage. So taking all the storms that made landfall in the past and approximating how much damage they would do today, given today's values of population and wealth along the coast. And it's not to say, obviously, you can't get nasty damage from a tropical storm. Obviously, last year with Imelda, it was a tropical storm for just a few hours before it came on shore and made landfall. And winds were a non-event, but obviously we saw a tremendous amount of flooding from that storm. But in general, the more intense the hurricanes and major hurricanes are the ones that generally go down in the history books. And when you're trying to predict the hurricane season, you can get a marginal named storm forming in a not a particularly conducive environment. You don't need a super good environment to form a named storm. But to get a hurricane, or especially a major hurricane, the environment needs to be quite conducive. So we look at things we talked about in this discussion. We look at things like warm water. Warm water means more fuel for the storms. You have low shear. You have plenty of moisture. You have to have all those conditions there to get a hurricane or a major hurricane. And so when we look at the seasonal forecast, we're looking at overall how conducive the large-scale environment is. And so you can get marginal storms in not a particularly conducive environment, but to get these long-track major hurricanes, that requires a large area of a conducive environment. And so that's what we're better able to predict with our seasonal forecast is kind of the overall large-scale environment, which is going to correlate better with the number of hurricanes or major hurricanes than just say the number of storms, which is a little more volatile.
Well, Phil, Carl, thank you guys for joining us tonight. To our listeners, we hope you learned a little bit about what to expect in this upcoming season. The best time to prepare for hurricane season is before it starts. So be getting your preparedness kits together, especially if you're living near the coast. And even if you live a little ways off the coast, these storms can certainly barrel through and cause many issues, not just wind, but storm surge, and we can even have storm surge well inland. So as we move into the season, we will be keeping you guys updated, and thank you for tuning in tonight to the Carolina Weather Group.